all, welcome back. So, in yesterday's video, we have discussed some important frequently asked questions in Verilog. So, we'll be continuing that in today's session. We'll be discussing about some more important frequently asked questions in Verilog. Okay, if you are new to the channel, consider subscribing this channel and hit on the notification bell also. Also, if you have any doubts in Verilog or system Verilog, you can ping me. I'll try to answer them as soon as possible. So, coming to today's question. So, the first question is write a Verilog program to switch the contents of two registers. That means you have to take two registers and you have to swap what are the contents that are present in one register into the another register. So, here the condition is that you can switch it by using a temporary register, and if you are switching it without using a temporary register, how is it going to happen? Okay, so these are the two conditions. So let's see the first condition, like by using a temporary register. So how you are going to write a code for this particular thing? So since there are two registers, let us take them as x and y, and let us take the temporary register as temp. So always at the rate of passage of clock. So we have already discussed about this, always at the rate of passage of clock. This is the sensitivity list actually. Okay, so for every passage of clock this block will be executed. So within begin and end I am writing the logic. So whatever content that is present in y, that will be switched to temporary register, and whatever content that is present in x, that will be switched to y. So now what happens, whatever that is there in x, that is switched to y. Now whatever that is there in temporary register, that will be switched to x. So for example, if you are taking x as 5 and y as 3, now what happens, the temporary register doesn't have any value. Okay, by default maybe it is some 0. Let us consider it as 0. Now what happens, now you have to swap the values such that x equal to 3 and y equal to 5. So how are you going to do it? So first whatever that is there in y, you are going to register it into, send it into temp. So here what is happening, y is 3 actually. Yes, so that value is given to temp. So now temporary register is 3. Now what is happening, so since if you see here, this is the blocking assignment. So since this is the blocking assignment, until the assignment is done, then only it will go to next statement. That means until temp value is 3, the execution doesn't happen for this statement. Now after temp equal to 3, then what is there in x? X is actually 5, so 5 is given to y. So now the y value is 5. Okay, now whatever that is there in temp, that is given to x. So what is there in temp? 3, so that is given to x. So now you see, these are the things that we want and these are the things that we achieved. Got it? So this is how you will be swapping the values. Now if you shouldn't use temporary register, what are you going to do? If you can't use the temporary register, then you can simply do it by using the non-blocking statements. Okay, that is x equal to y and y equal to x, as simple as this. But you may get a doubt here, what if we are giving as x equal to y and y equal to x by using the blocking statement? Now what is the thing that is happening here is, this thing we have already discussed in previous video also. Okay, but I'll just explain it one more time. So if you see here, okay, x value is, for example, let us consider x is 5 and y is 3. Okay, so now x value is 5. Now what is y? Y is 3. So that is assigned to x. So x value is 3 here. After the execution of this statement, then this execution will be done. Now what is x? X is not 5 but 3, because it is replaced with 3 in the first statement. So now x is 3. So what is the value of y? Y is also 3. So the output will be x equal to 3 and y equal to 3. But is it swapping? No, right? So now if you do the same thing with non-blocking assignments, what happens? First, y value is assigned, because in non-blocking assignments all the RH statements will be evaluated first. Then after the end of the last statement, then the assignment to the LHS is being done. So what is happening here? What is y? 3. So y is assigned as 3, but the assignment to x is not done here, and x is evaluated as 5 here. Okay, now since there are no other statements, now the assignment is being done. So what is x? X equal to 3, y equal to 5. So this is what swapping is happening. Is it or not? So by using non-blocking statements, you can simply assign one swap the values without any temporary register. But if you want to use a blocking statement, then you have to definitely use a temporary register in order to switch the contents from one register to another register. Got my point? So this is about this particular question. Okay, so this is also one of the frequently asked questions in interview. Now, when should you use task instead of functions? This thing also we have already discussed. But as I told you in the previous video, we have discussed about what is the difference between functions and tasks. Similarly, when should you use task instead of, from that difference only you can understand. For example, when you need to make a, when you are having a code which doesn't contain any delays and which doesn't contain any non-blocking assignments and which has at least one return type and a single output return type, then in such cases you will be using function. But if this is not the case, for example, as I told you in the previous video itself, we will be designing more complex circuits or more complex designs. So every complex designs will be having their complex behavior. So in order to design such complex circuits, we need some delays or else we need some non-blocking assignments. Okay, so in order to do all this, task is better when compared to function. That is why, as I told you, you should use task instead of functions in Verilog when you need to perform a sequence of procedural actions, that when you want to perform non-blocking assignments, when you require multiple input and output variables, because in functions you can use only one output. Okay, so that is why when there are multiple input and output variables, when there are multiple return types, okay, that means there are so many values that you need to return, that the particular task should return. So in such cases you will be using the task instead of function. Okay, tasks are more suitable for modeling complex behavior of the circuit. They can contain why, because they can contain blocking assignments as well as non-blocking assignments, because there are no such limitations to tasks. Okay, task can handle anything, but whereas function, it could handle only some particular functions, some particular concepts. Like you can use only blocking statements in functions, but you can't use non-blocking statements, you can't use delays. So this is why you generally use tasks more compared to that of functions. Okay, when you want to design more complicated circuits, so the process within the circuit is also very complex in nature. So in order to do all such things, we prefer task compared to that of functions. Okay, so this is the answer for that. Now, next question. Can race conditions occur in Verilog? How to avoid those race conditions in Verilog? Okay, so this is also one of the most frequent last question, and this is the important concept in Verilog, because in Verilog we encounter this race around conditions. So what is actually this race around condition and how can we avoid it? Okay, so race around condition can occur in Verilog. So what is this race around condition is, for example, as we have discussed, because we are designing circuits, when we are designing the circuits we need to write various logic codes for that. Okay, so while you are writing the code for various components, all these components should run in parallel sometimes, because when you see when we are talking about initial and always blocks, okay, so we will be using these two blocks in order to write our logic. So basically when you start execution, all the initial blocks and all the always blocks will start at zero delay time only. Okay, that means all they will be running parallelly. So during this parallel process of running all this code, there may be some situation where some two particular variables need to execute at same point of time. Okay, that means in different orders. That is what here if you see, like a race around condition arises due to concurrent events happening in different orders. Okay, that means two two events are being happened at same point of time and different. For example, if you are using some initial block and always block within your code, and there is some process within this always block and there is some process within this initial block, so both of this will be happening at zero time delay only. Then the simulator doesn't understand what to execute first and which should execute next. So that is why what it will do, it will just give some error value or some default value for those two things. But that is not what we expect, is it or not? So this is what race around condition means concurrent events happening in different orders at the same time. So the final output depends on order of timing of these events. So basically when okay, when it is happening concurrently, if you are giving delay for some events, then based on that delay time, they will be executing. But if you are not giving delay, and as I told you, at zero time delay or else at some 4 time unit, two particular sequences are happening at 4 time units of time, then the simulator doesn't understand which to put first and which to execute next. So that is why there in such cases you will be having this race around condition. So how to avoid it? Because we can't tell that the race around condition happen in the, if we see the logic correctly. So how to avoid them? Okay, there are certain things we could do in order to avoid such race around conditions. The first thing is use non-blocking assignments with sequential logic. Generally for combinations, okay, for, you will be that's what combinational logic and sequential logic, this is what we basically design for our circuits. Okay, so for combinational logic, you will be using blocking assignments, and the sequential logic, you will be using non-blocking assignments. So, because sequential logic is more complex compared to that of combinational logic, so for sequential logic, if we are using non-blocking assignments, what happens in non-blocking assignments? There is no such thing like everything will be executed at particular, because here the race around condition will be avoided. Why is it? Because in non-blocking assignment, this non-blocking assignment will be executed in the region of non-blocking assignment region. Like if you see, this is active, inactive and non-blocking assignment. So after all the statements that are executed in active and inactive, then the non-blocking assignment occurs. So that is why there is no much clash when you are using non-blocking assignments for sequential logic. That is why this is one way in order to avoid race around conditions. Avoid mixing blocking and non-blocking assignment within the same always block. This is also one of the reasons. Like basically, when you are using always block, try to write two always blocks. One always block for blocking assignments, another always block for non-blocking assignments. So that you will avoid the race around condition. In order to avoid some mix match conditions, you should do this. Okay, this is one way. And use separate always blocks for, this is what, combinational and sequential logic. Similarly, just like always blocking and non-blocking is nothing but combinational and sequential logic. Basically, as I told you, every combinational logic will be written by using blocking assignment, whereas sequential logic will be written using non-blocking assignment. So try to keep all the logic or blocking assignments and non-blocking assignments in a sorted way, so that you can know, okay, so that it is easy for you as well as for the simulator to understand, okay, these are all combinational logic and this is about the sequential logic. So the execution will be done in proper amount of time. Okay, and then the fourth thing is you ensure proper clock domain crossing techniques when dealing with multiple clock domains. That means when basically you will be using only one clock, okay, but when you are designing complex circuits and when you need to use multiple clocks also, take care that there won't be any clock mismatch. Okay, if you are doing this, then it will be fine, right? So there shouldn't be any crossing of clock domains while you are using multiple clock domains. You should ensure that. Okay, and then use the dollar stop system task instead of dollar display system task. This is also one of the important thing. Why? Because if you are using dollar display, generally everything will be executed in the active region itself. Okay, so when you want some delay to happen for that particular display, then you can go for dollar strobe instead of dollar display, so that it will be executing after all the non-blocking assignments are executed, so that there won't be any clashes between the dollar display and dollar strobe display units. Okay, so this is one of the another step. So by following all this, you can avoid the race around conditions in Verilog, right? So this is about race around condition, and these are the steps that you should ensure in order to avoid the race around condition. So this is one thing. Now, the last question is, what are three types of coding in Verilog? This you already know about this. Okay, if you are familiar with Verilog, you will not only Verilog, either VHDL or Verilog also, you know basically four types of coding technique, modeling techniques are there, which is like structural. Okay, switch first is switch level, structural, behavioral, and then data flow or RTL. Both of the same, like either RTL, which is register transfer level coding, or data flow coding, structural or gate level coding, switch level and behavioral level. Here in structural you will be using gates. Okay, in data flow you will be using operators in order to mention the logic, and in behavioral you will be using some conditional statements and all, like loops. Okay, by using these loops and conditional statements, you will be building your behavioral level logic. By using operators, you will be building your data flow logic. By using the gates, you will be building your structure logic. And when coming to switch level is not included when it comes to Verilog, because the one logic behind not including switch level is that basically, as I told you, we are using this Verilog and system Verilog or else UVM in order to design the complex design circuits. Okay, when you are writing the code for this complex circuits, you don't go to the level of CMOSes and NMOSes in order to design the circuit. Is it or not? Because when you are always thinking about that is why if you see here, behavioral level is called as highest level of abstraction in case of this Verilog, and gate level is called the lowest level of abstraction. Why is it? Because when you are designing the complex circuits, you even don't go to the level of gates itself in order to design a circuit. Then how are you going to the level which is even lesser than that, and you think about how many PMOSes and NMOSes that circuit was designed of? Is it or not? That is really foolishness. Similarly, when you are designing a complex circuits, you mostly use behavioral, or else in some cases you go for data flow. That's it. The gate level is also very least used one. Basically, when you are designing some combinational circuits, then you may use this gate level modeling, but other than that you don't even use the gate level modeling, or we also call it a structural level modeling also. So mostly you go for behavioral level modeling or data flow modeling. So by knowing how the data is flowing between the circuits, you will be designing the circuit by estimating how the data is flowing between the circuits in data flow modeling, and by knowing the behavior of the circuit. Basically, when you are designing a circuit or something, you will be given some specifications in your spec. Okay, so taking that specifications into consideration and estimating how the behavior of the circuit is going to be, based on that you will be writing the code. Okay, based on that you will be writing using the logic. So because of that, mostly behavioral and data flow modeling are the two modeling techniques that you use. Okay, you go for gate level also for the least thing. Basically, when you are a design or verification engineer, gate level is very lessly you will use this gate level modeling very less. Okay, but when you go to other domains like when you are going for DFT, okay, so in such cases you may be using this gate level modeling also. Okay, so these are some of the most frequently asked questions in this Verilog. Okay, there are also some other questions, and if you want me to explain those questions also, you could ping me in the comment box. If I get more requests from you regarding how to discuss about this particular concepts, then I will definitely answer your questions. Okay, so that is all for today. Thank you all.